Welcome to Topic 10 Notes. All right, so for Topic 10 Notes, what we are talking about today is actual real world problems and how we can find their equation. This topic is going to go really fast, so please stay focused. So we're doing writing quadratic functions. So let's take, for instance, this right here. It says a model rocket was fired upward at an initial speed of 60 meters per second. The table shows the rocket's height at X seconds. So here goes the time. Here goes the time, right? So at 0 seconds, the height was 0, which makes sense, right? No time has passed. They haven't shot it up yet. At 2 seconds, the height was 100. 4 was 174. At 6, 190. And then it starts to decline, right? As more time went on, the height went back down. And then the height went back down more, and then it came back to the ground. So when height is 0 at 12 seconds, then it came back down to the ground. So what we need to do is we need to take this information right here. We need to plug it into our calculator to find, and we need to estimate an equation for the given data. So here's how we do that. For you guys, you're going to use Desmos if you're at home watching this video. I'm going to show you how to use Desmos in a minute. But if you're at school watching this, here is how you use a calculator, okay? So I'm going to go ahead and bring my calculator up, put it right here. So first, I'm going to do second plus 712 to, second plus 712 to clear my calculator. So, all right, so that's the most important part, to clear it. I can actually bring this to the side. All right, bam. Now what I need to do is I need to take these values here and plug them in. Here's how you do that. So if you hit stat right here, so you hit stat, and then there's edit, so we need to hit enter. Okay, so what we need to do now is I need to type all these values here into my list 1, and then all my height values into my list 2. All right, so we have 0, enter, 2, enter, 4, enter, 6, enter, 8, enter, 10, enter, 12, enter. Bam. Okay, cool. Now we go to the other side. I have 0, enter, 100, enter, 174, enter, 190, 174, 100, and 0. Bam. Okay. Now that I have all these values in my stat list, what we need to go back is, here are the directions. Press stat, enter them into L1 and L2. Then the next direction says press stat again, calc 5 regression. So, and it says then enter 5 times. So stat says go to calc, so scroll over to the right. We need number 5. This is quadratic regression right here. So click that one. And mine doesn't do it, but I'm gonna have to do it again. So stat, calc, quadratic regression, bam. So then it tells you should have a list like this. At the bottom, you should say calculate, and then you want to scroll all the way to the bottom, or you can press enter 5 times, and then here is what we get. So then here is my quadratic, here's my estimated quadratic equation. So we're going to take these values, we're going to round to the nearest hundredths place, so that's 2 places after the decimal, and we're going to put it in this form right here, in this form. So here we go. So my equation is y equals, so I'm going to say negative 5.37x squared, right? Because let me, I'll write it in a minute. Then it's plus, plus 64.423x, and then minus 1.95. Now the reason it's written like that is because it's in standard form. Y equals ax squared plus bx plus c. So it's in standard form right now. So that's what standard form is. So now we take that, and then that's how we do that. Let me explain how you would do it into Desmos. At the very bottom of your canvas, you'll see, actually, I'll just show you real quick, just so you guys are not confused. So I'm gonna go to Canvas real quick. Here's a teacher. All right, I'm gonna open my course. Give me 1 sec, sorry guys. No courses, what? All right, files, studio. It's because am I connected to the internet? Of course I'm not connected to, yeah, I am, Birdfield guys. All right, cool. All right, here we go. Algebra honors, awesome. Go to modules, yes. All right, so if you go down to quadratics at the very, very bottom, if you see this right here, this says quadratic regression calculator. Right now it says it's not available, but I'll make it available to you guys. You want to click on this, and then it's going to bring you to this right here. It's going to bring you to this screen right here. Now, what I want you guys to know is that for your quadratic, when you click on that link, your table over here is already going to be filled out. All you need to do is delete each one of these values in the table that's already filled out, delete the X's and delete the Y's, and then put the information you want. Okay, so I did that. I did it too to show you what it looks like. I don't know why this is acting weird. All right, to show you what it looks like. Bam, so here's the graph. When I put these values in right here, so 0, 2, the same values like I did in my calculator, it tells me down here what my A, B, and C values are, right? So look, here's my A value. It's negative 5.4, what I got, or 3.4, what I got as well. B value is the same number I got, and C value is the same number I got. So you're gonna be using Desmos calculator if you don't have a graphing calculator at home. All right, so going back to this real quick, here we go. All right, so step one was write the equation, and we did that, right? We did that using this calculator the quadratic regression. Okay, step two says, or the next part of this says, what is my domain? Now let's think about this. Domain for a quadratic, when we're not talking about a real world example, it is all real numbers. But let's think about this, because here are my domain values right here, and then here are my range values. Does it make sense for me to go, and then remember, all real numbers means from negative infinity to positive infinity. Does it make sense for time to go to negative infinity? No, right? Because that means it'd be like traveling back in time. So really, my domain values right now, in a real world example, it's going to be whatever they've given me. So your domain will be from here to here. So your x values will span from 0 to 12. So we have to write that inequality statement. So your domain values are going to go from 0 seconds to 12 seconds. And we're talking about domain, so that's x values. So your x values must be greater than or equal to 0. So yeah, x values must be greater than or equal to 0, and then less than or equal to 12. That's your time. So there goes your domain. All right, cool. Now we need to find my range. Now my range, again, right, I'm not going to go from negative infinity to positive infinity for my, well, actually, for range, it's never going to be all real numbers. So we have to think about this. It's going to be the same as the time. What is your lowest y value? And then what's your highest y value? Here's your highest and here's your lowest. So our range is going to be in between there. Okay, so our range is going to be from 0 to 190. And we're talking about y values. Because I have the smallest number on the left and the greatest number on the right, my values will always open up like that. And then bam, that's it. All right, so we've done that. So we're going to do this one more time. Okay, so here we go. What does it say? It says, in class, Jerry launched a model rocket from the ground. Given the table, what is the maximum height reached by the rocket? So here we go. So we're given this table right here. And we have actually some missing information. So step one is we need to put this into y equals. We need to find that equation just like we did up here. Here's what I want to recommend. I'm going to go ahead and pause the video and try to do it yourself. But before you try to do it yourself, stop right here. Plug all of these in, not this one yet, because if you plug in a 12 without its corresponding y value, you'll get an error. So plug all of these values here and then see what your equation is. So let me go ahead and let's go ahead and plug it in real quick. I'll plug it in Desmos this time so you guys see how I'm doing it in Desmos. Let me bring Desmos up, go here, bam. Let's bring that. So let me make this smaller. So like I said, we need to go up here and I need to delete all these values. So let's see right here. So I'm gonna go ahead and just use my keyboard, delete. I'll delete all of these real quick. Go over here, delete, so I can retype them all in. All right, cool. So I have 2, 4, 5, 7, 9, 11. And I'm gonna stop there. I'm not gonna do 12 yet. So I'm gonna go over here now, 100, 174, 186, again 186, 143, and 57. Bam. Okay. Now that I've typed all my values in, let's scroll down to see what A, B, and C values are. Okay, so I have my A, I have my B, and my C. So let's go on this side here. I'm gonna see if I can make this a little smaller. Can I do that? Can I get rid of that? All right, bam. So I have my A, B, and C values now, right? So let's go and write my quadratic equation. I'm going to round to the nearest hundredths place again. A value is negative 5.6 still. Negative 5.56, sorry. X squared. And then what is my B value? Plus 67.20, or just 2, X. And then C value is minus 10.0. 21. Bam. Okay, I have my estimated equation, right, for my quadratic equation for this given data. All right, so there's a few things we need to do. We need to figure out, right, what it asks us, what's the maximum height reached. So one way to figure that out is, let's think about this. Right now we're jumping across, right? We're at 2, we're at 5, we're at 7. And right now it shows that 186 is the highest number, but we're missing we're missing some seconds in between here, right? So what we need to do is we actually need to graph this quadratic, right? Put it in a table and see if the vertex has a higher, or if the vertex is higher than this value they've given us. So we're going to do that in a minute. Let's go ahead and try this real quick. Here's what happens. So I'm given an x value, but I don't know the y value. How do I find that? Well, just like any other function. If I know my x value and I know its equation, I'm going to take this x value, I'm going to plug it in here, I'm going to plug it in here, I'm going to plug it into the calculator, and then we will see what we have. Okay, so that's what we'll do too. Let's actually find the vertex first. So how do we do that? I'm going to close this off. If you have your calculator, go here, bam. So now we need to go to y equals, right? So go to y equals. Now I'm going to type this equation right here in this box right here. Let's go ahead and type that real quick. -5. Ooh, negative. Why is it not working? Negative. What is happening? Quit. Clear. Y equals negative. Dude, what is happening? Negative? Okay, 5. Sorry, -5.56 x squared plus 67.2 x minus 10.21. All right, graph that, bam. Right now, I can't see anything. So what you need to remember is we have to zoom out. So I'm gonna hit zoom, and I'm gonna scroll down to where it says fit. So right now it says zoom out, zoom decimal, zoom square, trig. This says zoom fit. So it can fit my screen, so bam. There's my parabola right there. And now I can actually see my vertex is somewhere right here. My vertex is somewhere right here. Oh, it actually tells me right here, max. Here's what my vertex is. Now, if your calculator doesn't automatically do that, here's how you do that. First, you must identify, is this a max or a min? And we know this is a maximum, right? Because this is the greatest y value. So I'm gonna hit second, trace, and then we wanna find the maximum. So I'm gonna hit max. Now what I need to do is, right, if I'm using my calculator, I need to do left bound. So I need to go on the left side of that vertex to tell it where to scan. So here, I'm gonna go right bound. I'm gonna go somewhere over here, past that vertex, because I need to put on the right side, press enter. There's my vertex right here. So let me just write that. So your vertex is round to nearest hundredths place, 6.04, comma, 192.84. Bam. So what does this mean? Remember, x values means time, and then y values means height. So real quick, let me throw this away, bam. So this is time, and this is height. So what does this mean? This means at 6.04 seconds, the maximum height it reached was 192.84 meters. So this information they gave us was not the highest value for the height. The actual greatest height was 192. So this is the max height right here. So max height. All right, and then, the last part is, what is the height at 12 seconds right here? So we're gonna take this in. So the way you do that is, we're gonna take this x value, plug it in. So we have y equals -5.56 parentheses 12, because that's what I'm plugging in. Make sure we square that, plus 67.2, and this is times 12, minus 10.21. Okay, I'm just gonna go ahead and for the sake of time, I'm gonna tell you guys. When you plug this in, you will get y equals -4.45. So -4.45. But now let's think about this real quick. What am I talking about? I'm talking about time, realistically, right? Time. Height. Can I have a negative height? If you would kind of think about this, this would mean that the rocket would have to dive through the ground, and we only start at 0 and we go higher. So this realistically does not make any sense. So if we're in the negative range, basically the rocket has landed. So what height am I at? I'm at 0. So we're just going to say the rocket is on the ground. We'll say at 0 feet, or meters, sorry, meters. Bam. All right, so your homework consists of that. Basically, all you need to do is you need to look at the tables they've given you. You're going to plug these values in, and you're going to find your A, B, and C value, and then you select the right answer. Now, again, if you don't have a calculator at home, you need to use Desmos to do that. Use the table that they've given you here and your regression. So you're going to be using that. So good luck, guys.